Hello everyone. So welcome to another revision lesson where we discuss the solutions to question 5 of analytical geometry. Right. So here we have a diagram where A, B, and C are the vertices of a triangle. AC is extended to cut the x-axis at D. Right. So 5.1, but calculate the gradient of AD and the gradient of BC. Right, so the gradient of AD is the gradient of this line, right? And then in order to calculate the gradient, we need 2 points, right? So we have the line laga AD, we have point A and we have point C, right? Point A, C, and D, they all lie on the line of AD, right? So if we calculate the gradient of AC, of the line AC, it will also be the gradient of the line AD, right? So 5.1.1, to calculate the gradient of AD, we will say AD MAD is equals to y at A minus y at C divided by x at A minus x at C. So we go to our diagram and see what is y at A. We see that y at A is 7 and then y at C is 4, right? And then x at A is 3, x at C is minus 3, so here we'll have plus 3. Therefore our gradient will be 7 minus 4, which is 3, and 3 plus 3, which is 6. So the gradient of AD is 1 over 2, right? So I'll write the answer here, 1 over 2, right? Okay, and then 5.1.2, the gradient of BC. The gradient of BC, it's MBC. We're going to look at y at B minus y at C all over x at B minus x at C, right? And then we see what is y at C, y at B. Y at B is minus 6, therefore when we see y at B, we just put minus 6. And then we go to the point C. What is y at C? Y at C is 4, so here we'll have minus 4, right? And then we see with the x at B is 1, so here we just substitute 1. And then x at C is minus 3, so here we'll have plus 3, right? So here we'll have minus 10 over 4, which is minus 5 over 2. So the gradient of BC is equals to minus 5 over 2, right? So now we move on to question 5.2. Okay. So 5.2, they want us to calculate the size of the angle DCB, right? So the angle DCB is this angle here, right? So in order for us to calculate this angle, we need to calculate this angle. I'll call it alpha. This angle at D, I'll just call it alpha. And then this angle at this point, I'll just call this angle beta, right? Okay. And then in order to calculate these angles alpha and beta, I'll use the gradient of AD and the gradient of BC to calculate these two angles. Okay, so now to calculate these angles, let us start by calculating the angle alpha, right? So remember, we said there's a relationship between the gradient and the angle of inclination, right? We said if we have a gradient of a line MAD, that gradient should be equals to tan theta. So, right, in this case, our gradient, our angle of inclination is alpha, so here we'll have tan alpha, right? So the angle of inclination of this line AD will be alpha, right? So the gradient of this line is equals to tan alpha, right? So therefore the angle alpha is equals to tan inverse of the gradient of AD. We calculated the gradient of AD to be 1 over 2. So alpha will be tan inverse 1 over 2. And then we'll get alpha to be, if we punch in our calculator, alpha will be 26.57 degrees. Right, so that angle there is 26.57 degrees. Right, and then now we're also going to use the gradient of the line BC to calculate the angle beta. Right, so firstly I'll just calculate because the angle of inclination is measured from the positive x-axis to that line, so I'll just name this angle theta. I'll first use the gradient to calculate theta, and then use the concept of angles in a straight line to calculate beta. Right, so beta will be equals to 180 degrees minus theta, because they are angles in a straight line. Right, so to calculate theta, I'll use the gradient of BC. So theta will be tan inverse of the gradient of BC, which is minus 5 over 2. Right, now because this is sort of like an obtuse angle, or I'm taking tan of a negative number, I'll get a negative angle here. Remember, we said the angle of inclination needs to be between 0 and 180 degrees, so I cannot have an angle of inclination as a negative angle. Right, so if you say tan inverse of minus 5 over 2, you'll see that is equals to minus 68.19, right, which is a negative angle. So instead I'll add 180 degrees to have a proper obtuse angle. Right, so I'll have theta to be tan inverse minus 5 over 2 plus 180, which is gonna be 111.80 degrees. Right, so now that I have theta, I can go back to this concept of angles in a straight line to calculate my angle beta. So beta will be equals to 180 degrees minus 111.80 degrees, which is 68.2 degrees. Right, 68.2 degrees. Right, so now I have angle beta, I have angle alpha. I can calculate that angle DCB. Right, so the angle DCB will be equals to, the sum of angles in a triangle is equals to 180. Now if I say 180 minus alpha minus beta, I'll get that angle at C. Right, so here I'll have 180 degrees minus the angle alpha, which is 26.57, and then minus the angle beta, which is 68.2, and then I'll get my angle DCB to be equals to 85.23 degrees. Okay, so this angle is equals to 85.23 degrees. Right, and then we're done with 5.2. Moving on to 5.3. Lapho 5.3, but write down an equation of the straight line AD. Right, so we already have the gradient of AD. Remember, the equation of a straight line is in the form of y is equals to mx plus c. Right, mx plus c. We already have the value of m, that gradient of AD, which is 1 over 2. So now my equation is just y is equals to 1 over 2x plus c. Right, so now I need to calculate c. In order to calculate c, I'll use this. So we want the equation of this line AD. Right, in order to calculate c, I can use one of these points, A or C, to calculate the value of c. Right, so if I substitute the point A into that equation, I know if I substitute 7 and 3, I can solve for c. Right, when x is 3, y has to be 7. Right, So now C is equals to 7 minus 3 over 2, which is equals to 11 over 2, right? Okay, so therefore the equation of the straight line 8 is equals to y. 1 over 2 is y equals to 1 over 2x plus 11 over 2, right? So here I'll have y equals to 1 over 2x plus 11 over 2. That is 5.3. And then 5.4 batini. 5.4 but it determine the coordinates of M, the midpoint of PC. So M is the midpoint of PC. We know Uti. To calculate the midpoint of PC, we'll need to calculate the x coordinate of the midpoint and the y coordinate of the midpoint. Right, so the x coordinate of the midpoint is x at B plus x at C divided by 2, and then the y coordinate is y at B plus y at C divided by 2, right? So now I can simply substitute the values of x at B and the values of x at C, right? X at B is 1, right? So here I'll put 1. X at C is minus 3. There I'll put minus 3 divided by 2, right? And then y at B is minus 6. Y at C is 4. So here I'll have minus 2 divided by 2 is going to be minus 1. And then here I'll have minus 2 divided by 2 is going to be minus 1 also, right? So the coordinates of the midpoint of M, the coordinates of the midpoint of BC is minus 1, minus 1. Okay, and then now we go on to 5.5, right? Okay, so 5.5 party, if G is a point such that A, G, M lie on the same straight line, show that B is equals to 2A plus 1, right? So if A, G, and M lie on the same straight line, we'll have a straight line connecting these points, right? A, G, and M, right? So now, in order for us to show that B is equals to 2A plus 1, we will need to find the equation of this line connecting all these 3 points, and then substitute that x value of A to determine what B is equals to 2A plus 1, right? So now to do that, we'll have to calculate the equation of the straight line AM, right? So 5.5. So I'll calculate the gradient of AM by saying y at A minus y at M divided by x at A minus x at M is equals to y at A is 7, y at M is minus 1, so here I'll plus 1, x at A is 3, x at M is minus 1, so here I'll have plus 1, so I'll have 8 over 4, so the gradient of AM is 2, right? So we know what the equation of a straight line is in the form y equals to mx plus c, but then I already have the value of m, which is 2, so my equation is y equals to 2x plus c, right? So now I'll need to calculate the value of c. In order to calculate the value of c, I'll just use the point A and substitute it in here. So where I see y, I'll just put 7, and where I see x, I'll put 3, right? So now I can solve for c. So c will be equals to 7 minus 6, which is 1. Therefore, the equation of the straight line AM will be y is equals to 2x plus 1, right? So now we want to show what B is equals to 2a plus 1, right? We notice what B is the y coordinate of G, right? So we know what at G x is equals to a, right? So now, and then also at g, y is equals to b, right? So in this equation of the straight line, where I see x, I'll just put a, and where I see y, I'll just put b. So b, where I see y, I'll put b. So there is y, I'll just put b. And then where I see x, I'll put a. So there is x, I'll just put a. So I'll have 2a plus 1, right? If you substitute, because at g x is a, I'll put a there. And then because at g y is b, I'll put b there. I hope that makes sense. Therefore, this proves that b is equals to 2a plus 1. Okay, so we have shown that b is equals to 2a plus 1. We can go ahead and calculate the values of b, Lapogo 5.6. So I'll just erase here. Okay, oops, we don't want to erase everything. Okay, so now we go on to 5.6. So I've got 5.6, but hence calculate two possible values of b if GC is equals to the square root of 17, right? So GC is that line connecting G and C. So GC is this line, right? And then they tell us with the length of this line. GC is this line connecting G and C. They tell us the length of GC is the square root of 17, right? So we know GC is equals to the square root of 17, right? Syllable 5.6. And then at the same time, we know the length of GC can be calculated using the distance formula by saying x at G minus x at C all squared plus y at G minus y at C all squared is equals to the square root of 17, right? So x at G is a, so where I see x at G, I'll just put a. X at C is minus 3, so here I'll have plus 3 all squared, right? Y at G is b, but then we show b is equals to 2a plus 1. So where I see y at G, I'll just put 2a plus 1. So there is y at G, I'll just substitute with 2a plus 1, right? Minus y at C is 4, so here I'll have minus 4 all squared, right, is equals to the square root of 17, right? So now if I square both sides, I'll just remove the square root sign, and then I'll have a plus 3 squared plus 2a plus 1 minus 4 is going to be 2a minus 3 all squared, and then here I'll just have 17, right? And then now expanding these brackets, here I'll have expanding a plus 3 times a plus 3, I'll have a squared plus 6a plus 9, right? And then expanding 2a minus 3, and saying 2a minus 3 times 2a minus 3 will give me 4a squared minus 6a minus 6a, which is minus 12a, times minus 3 times minus 3, which is plus 9. So it's gonna be equals to 17, right? And then I just collect like terms. So a and a squared plus 4a squared will give me 5a squared. 6a minus 12a will give me minus 6a. 9 plus 9 will give me 18, and then I will bring in that 17 to this side. I'll have minus 17 is equals to 0. So I'll have 5a squared minus 6a plus 1 is equals to 0, right? So a, we can now factorize this and say 5a minus 1 and say a minus 1 is equals to 0. So this will give us a to be 1 over 5 or A to be 1, right? But then now we are interested in the two possible values of B, right? Remember B is equals to 2A plus 1, as we have showed lapha ku question 5.5, right? So now because we have the values of A, we can simply substitute in this equation here. So B will be equals to 2 times 1 over 5 plus 1, which will give us, punch in your calculator, which will give us 7 over 5, or B will be equals to 2A, which is 1 plus 1 will be 3. So B is equals to 7 over 5, or B is equals to 3. And then this concludes question 5. Okay, I hope you were able to follow my workings. If you were lost somewhere, feel free to let me know ukuthi ngikwazi ukuthi ngichaze ngconywana. Okay.